Okay, so DMC is here with Dave McComb. He's joining us from Colorado, President of Sematic Arts and frequent contributor on TDAN and Dataversity. Dave McComb is the author of 3 books, Semantics and Business Systems, Software Wasteland, and the Data-Centric Revolution from 2019. David, thanks for joining DMC from Colorado. How are you doing today?
We're doing great. Like I just told you, the snow just came in.
The snow just came in. Well, it is the season for sure.
Yeah.
So I'm actually, as I was saying earlier, I'm really excited about this upcoming event that's taking place on December 9th with yourself and John Gorman. Data-centric architecture has really been your wheelhouse now for some years.
Right.
It's truly kind of a paradigm shift from application-centric architecture towards a mentality where, and I quote, this is your quote actually, data is the primary and permanent asset, and applications come and go. So it's a real shift. So I'm interested if you can clarify first the importance of semantics in data-centric architecture.
Right. What actually first got us into this was when we started noticing the complete arbitrariness of data modeling. You know, people, even myself, I built a lot of enterprise applications back in my youth. And I just started observing what I was doing and what I was seeing. You know, if 10 different data modelers designed 10 different inventory systems, we'd have 10 different structures, 10 different names, 10 different everything. And then of course, you turn around and say, we now have to integrate this. You say, wait a minute, why do we have to integrate it? If they're all inventory systems, why is this hard? And you know, it was a problem of our own making. And this was back in the early 90s. There wasn't a semantic web or anything like that, but we just started casting around saying there must be some principled approach to design that would cause people to converge instead of diverge. When we uncovered something that was called semantic data networks at the time. There was no implementation, it was just an idea, but we just kind of ran with that and started designing along those principles. And we did find that things converge and that when the semantic web standards came out, we said that's a pretty good way to kind of force your thinking toward convergence. So that's where that got started.
Really interesting. So data-centric architecture, as I said, is a bit of a paradigm shift. So can you maybe outline both the challenges and opportunities for organizations that are thinking about moving towards a data-centric shift?
Yeah. The main challenge is inertia. Everybody knows, I guess it's inertia and the budgeting system. Everybody knows how to either build, buy, or nowadays software as a service, rent an application. And every time somebody has a business problem, there's an application to fix that. But every time people do that, and we're all now trained to do that, have a problem, implement an app, and you just keep doing that until you have an app, and they all have their own data model. They all exclusively manage it. They won't let you come in from the side and mess around with it. So the dual problem is inertia, what everybody knows and whatever they're used to, and the budgeting process. We've also accustomed ourselves to, let's budget for this big application implementation project. So, making the shift is both a shift in how you think about the problem. I heard a very interesting talk recently from Jans Osman, who's with Franz, but he was saying the real difference is a typical, and he said typical relational, but it's really any typical application oriented person, when they sit down and solve a problem, will exercise about 0 neurons thinking about how this model is going to tie in or be affected by the rest of the datascape. And he says, whereas a semantic or a graph modeler will probably spend half of their neurons worrying about, wow, how does this fit in and how does it connect and where's it going to go? So in some ways, that's the first mind shift change. Stop solving. It's hard to not solve the immediate problem at hand. I mean, you've been asked to solve a problem and, well, I'm going to solve it in the context of something bigger, but that's really where you have to go. And when you start to get some momentum with that, it's that everything gets easier instead of harder. Right now, every time we implement an application, we've just made the world harder. And some, we were just talking to a large telecommunication company that shall not be named, but they've done one of the most thorough inventories of their datascape that anybody has ever done, and have discovered that they are now managing 200 million columns. That's quite a mind-boggling idea to me.
That is an unbelievable number.
200 million concepts. Every one of them is a different label on a different field, or it's on a form, or it's somewhere, and somebody has written code to 200 million labels and column names and stuff.
Well, that is, I mean, it's certainly, I would think in my experience, and I would think the vast majority of our viewers can certainly relate to that experience. So the app, I mean, there's always a new application, always a new architecture, like you said, whether it's one of the big names or whether it's in-house built. But in a hypothetical organization, David, where we've gone through the process towards data centricity, how does this all work in practice? And do we still encounter the usual suspects in terms of the enterprise applications playing within the sphere, or what does it look like, if you can paint that?
Yeah. Oh, I just had a weird echo. Let me paint the end game first, even though the end game sounds too fantastic, and then we'll kind of back up and say, what do you have to do to get there?
Great.
In the end game, an enterprise will have a lot of little applications that look more like the applets on your iPhone. Instead of monolithic, you won't go to, it won't even occur to you to have gone to a particular application to sit down there and page through their menus and do all that kind of crap. There'll just be one icon, one function, and it will do something. But, and the reason why we can't just do that right off the bat with our iPhones or our, Google Android phones is because those apps have almost no integration between them. Those apps on your phone, they all do different things. And you as the human are the little, maybe your calendar does a little bit of integration, but that's about it. Whereas for this to work in the enterprise, all of those things would have to be integrated, but it doesn't work if they all know about each other. So instead, they're all going to know about a single shared model. When the little inventory receipts app goes into the model, and you receive some inventory, or you do a cycle. There's another one for a cycle count, and maybe now you have fresh produce that you never had before, so it has a use by date. All of a sudden, it starts putting things in with use by date, but they don't know about each other. All they know about is the common model, and they both read from that in some ways like a data warehouse, but they also write to it. Anything they do, if they decide to create a suggested ordering quantity, that's just another piece of data going to the model, and there's already a conforming way for it to conform to that. And so there won't be these monolithic applications. There'll be lots of little applets. Perhaps the enterprise itself will pay developers, will give you $10,000 for a better cycle counting app or applet, or maybe $10 a month per number of users in our enterprise, something like that. So that's kind of what the end game looks like. That's so far from where we are now, it's kind of hard to imagine. Although frankly, when the iPhone first came out, there was no app store. It's now a $100 billion a year industry. It's only barely 10 years old, So anyway, it's not like that's impossible. It's just we're not there yet. So in the immediate term, people need to first, you need to get the model. There is even if you have 200 million attributes under management, there is a simple model that covers it all. And simple, every case we've seen so far, less than 1,000 concepts. So not 200 million, 1,000, let's say, even quite a bit less than that sometimes. So you figure out what that is, and then you begin bringing data you already have and conforming it to this model. Now, it doesn't all have to be co-located. This is not like a data warehouse or a data lake. You can co-locate it, or you can leave it where it is. That doesn't matter as much as knowing what it means and where you can get it. So then after a while, once you know at least some of your applications in this new model, you can begin saying, well, I could just write functionality to the new model. And every time you do, you can go back in a legacy system and say, wait, you don't have to keep entering that anymore. We got it here. We're ready. And, I think there's a path there to gradually get to that end game we described.
That's fascinating. The metaphor of using the iPhone as an example really actually for me brings it down to kind of like how that might actually look in the future. And I think it's a really fascinating architecture and approach that you're discussing, you and John Gorman on the 9th. And I'm really looking forward to having this discussion with you in just about a month from now.
All right. Yep.
Right.
No, me too. I'm looking forward to it. Great. Thanks, Wade.
Thanks, David.